I think I'm live. That seems to show that I'm live there. I might double check. On my other device that it's showing up. If I hit this and I think we're all right. Bring this here up. I'll be able to see, perhaps. See what sort of delay I've got between this and that. Yeah, it looks like I'm there. Okay. Alright, so there's two things that I sort of discovered or realized since that. No, I'd better close that off there. Since the stream earlier today. One is that apparently no matter how quiet you have music playing, YouTube will pick it up and pick up what songs they are and that sort of thing. So I should have just used my headphones. Number two is that I actually am close to the solution. I just got messed up a bit. So bring up these things, this artwork again. Let's make a new one for now. So essentially, let's go. I think that's this long. Instead of having two windows, essentially like following two windows around, what I should really do is just have a single window that I'm using, and that is keeping track of this position, this pointer here, and the size of a window. Right. So, and from those two values, I can then make the second window each round. And that's what I should be doing. So, so when I do this here, they'll divide that by 2, I'll get a 4. I want to subtract 1 from that to make it 3, right? So that would be this pointer plus 3 equals the end position, then add 1 to it to get the start of the second pointer, and then add 3 to that one there. So I'm just using 2 values to go through it. Then, you know, if this point here, after going through the 2 windows, walking the 2 windows, if this point here is on the last digit, on the last value in the array, we can say yes, this was an invalid ID, or no, it's not. Definitely not. If we make a new window and it goes past the end of it, then we can say this is definitely not a valid one. And if it ended before it, then we try to make another window to see where we go. So let's see if I can put this together, rewrite this up before, within like a couple of hours or something. So what I'm going to do here is I have to get rid of a bunch of the stuff here. I want to I want this here. The first thing I want to do is well, load this in. I want to check if one, oops, one, so one. First thing, I'll just check if that is a do I want to do that very first? I think I'll do that first. I think I'll do this first. Do I do that? I think I can say that for a second actually. Load byte there. So I've got the length of it. I want to do this thing here essentially. Yank this, put that there. Instead of moving it in there, I'm just going to put that in there. It's going to be my endpoint, final target. I want this one here. Put this in here. Oh, put that in. My window size, which is going to be we'll just in T6. Divide that by 2 and minus 1, subtract 1 from it. So those are the two values that I really need. Then I need to add 1 to S0. So that's my actual starting position. This one here. I want to AND this by that. Do I want to, I think I do want to put this S0 into, I think I do want to put this into here. Let's do a BQ T1 0 try it. And then I'll do the store double S0, put this into the stack, and it's 5 1. I don't have to worry about the odd start thing. I can just ignore that odd start thing. So what I'll do here, right, is that in the beginning of this, I'll create the window size here. So I'll add, and I'll put this into F6, S7 I think it was. S6 is going to be the ending for this one here. S0, T6, then you go add I, S1, S6, 1, then add S7, S1, T6. Right, so these are the windows, right? Make the two windows, right? When I come out of this, I've got a thing here where, you know, did we make it to the end? Did we make it to the end, essentially, right? if we didn't make it to the end, no, this is here first is like, if these two windows are not the same, if the two windows if the two windows are different, we try a smaller window. We go down to the smaller window. Landed on the last value and same, right? We landed the second window was ended on the last window and on the last value in our list of values in our number, and it's all been the same so far, right? So then we're done. Otherwise, right? Otherwise, now this thing here, I don't want this one here, I think. What I will do though is that I'll move S1 into S0. And that should be fine here. I think I'll just say it's going to be fine here. No, I think that's all I need there, so I can just not for these other ones. Oh. I think that's right. Oh no, I need one more thing here. One more check over here actually. I want to check set less than T7 S7 sorry, S2. So if S7, if T7 is less than S7, then that will be true. So if it's not equal to 0, then we go to walk try next. I think that should be good enough there. I'll set a knob there. This one here can now just go, and that there can go, I think. And that there is right. So what we do down here is that we subtract 1 out of this. If now in this case I want to check if this is greater than 0. I do. T6 0. If it's less than 0, then we break out. Otherwise, we're going to load out of S0, and we're starting again out of there, I believe. Oh, sorry, not odd. This thing here. We don't need the odd start anymore. This thing here is going to be down here. And yes. Actually. Something like that. Let's see how badly this goes, and then I'll that's an immediate one. Not not that. I want to have a look at the thing here. So if we reset this and I run it, it looks like every... Oh, we get a thing missed there. 10500C S0 has gone somewhere. It's gone up very high. That's not correct. That seems odd. And this also seems odd that they were all counting up there. Altogether, let's see, what did I do wrong there? I mean, obviously this window here could be an issue. 'Cause if, right, set less than, so if T7 is less than S7, then it should branch out to we'll try next, which is where we make this smaller and then load out thing from SP there, which was stored there. Oh, this one failed on this one here that has a really short input. So things, that one there started off less than 1 probably. Yeah, it's probably an issue, isn't it? Right, because that started off less than 1. This never went upwards. So I should just do like a if T6 is 0, return anyway. Walk upper end. Yeah. Let's see. So if it's ever 0, we're not going to find anything on here, so we might as well just bail out as soon as that is a 0 there. Now we'll still run the one where it's 2 length, because they'll start out as 1, and then we'll subtract 1 from it, and that will still sort of run the one time, and that should bail out. But I think so. Work for the first half. We got that one there. The correct answer. It did not work for the second half. I was hoping that it would magically work, but obviously I am dumb, so where are we? Here we are. I think we want this one here to be like, this is a Right, we've got this one. These ones are probably all working. Let's go for an odd number one, this one here. Right. 2, 2, 2. It should be all 2s along there, should be one of them. And it didn't pick up. So that seems to be one of the big sort of issues that I have, are these like 0 length ones. Right. Let's take me into this one here, I think it was, this one here. And let's set this up for a second. What was it? 09, 3, 4, 5, 6, 7, 8, 9. Right. So let's have a look at this for a second. We've got false, blah, d, blah, 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 blah. T is 0. We've got T6. T6 is a 3 because I subtracted 1 from it. It was a 4 before. We put that there down. I mean, it should pick up on the 3s one, really. We check that one there, that's false, so T5 is going to go to a 1 there. So now we're adding S6, so we're into this loop here, right? S6 is going to be on 104, we're on 1, 1, 2, 3, 4, it's there, it's going to end that one. We add 1 to that to make S1, yep, it's on the 5, and then we add that onto there, so we end up on 8, which is going to be there. It's not equal. We go into this walking thing, so I just step over that. It's not equal to a 0, right? It comes out as a 1 there, so it's false. If it's equal to S7, we do that check to see if it's equal to S7. It's S7 and T7 are not the same, so we're going to jump back up. We move S1 into S0, right? We back up here, we add onto that again. So it's 8. We add that onto there, so it starts on 9. We add on to that one there. And so now it's 10C, which is 12. And now this is true, so it's like, hey, we can't do this one. So we subtract 1 from T6 to make that gap smaller. We see if it's less than 0, and it's not. We load T0 back, S0 back. S0 is not the right thing. I stored S0 in 8, and that was the RA that was there. So that would explain why that did not work. Okay, let's make this 101 as it should be. We go up here again, we add that onto this, to T6, so it's onto 3, it's onto 4, onto 6. You go down here, everything comes out as expected. We jump up again. S0 is 4, it ends on 6, that starts on 7, it ends on 9. It's not less than, so we're fine. We run through this. it's a 1, so we're fine. It's S7 is equal to T7, so we've hit the end. And so we go down here and we make the value S5 is not equal to 0, so it's just the gold one, and we add it on. Yep, okay. That seems to be correct now. Did I save it? Did I remake it? Oh. Let's reset that. Let's get rid of those and run through it again. Oh, there we go. Yay. Yay, that's how close I was. 27469417404. And it's 1673817782. Yep, that's correct. It only took 5.5, 6 hours. It only took me half an hour to get it after that screw up last time. Now the question is, how long does this take? Before it was like 10 seconds. Let's see. Less than 2. Less than 2. There we go. 5 times faster. Now, for completion, what I need to do now is run it on the hardware. So I need to set that up. I need to turn on my things. Just a moment. And I need to switch. Actually, let's go like this, shall we? Let's bring that up. GBS control. Now I have this weird bug thing where I have to hit like a couple of these to make it actually turn on. Probably wait. Oh, there we are. No, it's working now. Okay. So I need to bring up, I need to add this to the scene perhaps. Is it just going to show up? Oh, nope. Maybe I need to add it in again. No, it seems to be sort of there. Oh no, okay. Maybe I need to add it to the scene again, because it seems to be somewhat buggy, maybe. Video capture, add this in, default things. Oh, there it is. Yes. Can I just transform this? Because the it's kind of hard to tell where the actual borders are, but we'll just cut it like that for now, shall we? So here is my PS2 thingy-bob. Put that there for now. Actually, I might have to move this over here because we might have to see or show actually launching it. File browser, here we go, the mass storage, PS2 link, bring that up. And I need to, which one do I need? Let's do this one here, shall we? So I need to go to here and do // to set phone up back. 1, 2, 3, 3. Oh, sorry, PS2. And then there, PS2 client, bin, PS2 client, minus host, 16.55 minus T1, because I put a 1 second timeout. That helps things go a bit smoother sometimes. Exec EE, host, day A2.elf. I think that's right. Hey, there we are. It hasn't shown up on the capture device though. It seems to be like weirdo. Why isn't the capture device showing it properly? Excuse me. There it is. It's probably a resolution change. It didn't like the resolution change, I'm guessing. Now let's see if it runs or if I get a TLB exception error. It runs. Nice. Alright, so yep, that's it. There is my solution, and I can reset the console with my controller as well. Perfect. That's wonderful. Great. Okay. Well, that's very good. I have accomplished the thing that I wanted to do. I got that working. Should we go? I'll go back through the solution again, shall we? Let's just have a bit of a look back at the actual solution that I've got here. So where are we? Here we go. So let's hide this for now. So what so what did I do again? So right, I have these two variables that I'm storing quads in, up to 16-digit numbers. Right and ASCII num. Right is sort of the end of a range. ASCII num is the starting of the range, and which is the one that we count up. We've got the input here, the beginning and end of the inputs. So we loop through our input. If S6 is equal to S7, then we're at the end of it. We want to solve the range. We also check if the thing is a 2D, which is a hyphen, in which case in which case we switch the mode. Either we're going the ASCII num or we switch to the right one. If it's a 2C, then we want to do a solve range. If it's a OA, which is the new line character, we want to solve range. Otherwise, we convert the character we loaded into a digit, and we store it into whichever range we're doing right now, either ASCII num or right, whichever is presently S2. We increment the input here. Switch range, we'll just switch S0 to right, to point to right, and then go into and then increment this again. If we get down to solve range, if the length of whatever input we were doing, either right or ASCII num, is 0, then we go to finish day. Otherwise, we go into the solver, and if we come out of the solver and S6 is equal to S7, then we're going to finish day as well. So that should generally make sure that we get out of there. I've got this next range thing here. I don't know where next range was coming from. Right. Of course, if we fall through this branch, then we end up in next range. which is when we'll clear out ASCII num and write, and then jump to increment this to go to the next input thing. So that's the loading the input stuff. At convert ASCII, I copied out of day 9. There's no real changes there. We're using shifts to multiply by 10 to start at the very top of the input. Add in multiply our sum by 10, our output by 10. Then add in each column, each digit, until we've made the binary representation of the number that we've read. Then we've got our solver here, which is just a big loop basically. We go through this walk helper, and then down here we've got a we load in these, we check if ASCII num is the same as write, the value that's in write. If it is, then we are finished. We'll go to solver end. If it is not the same, if there's a difference between them, then we'll go into the solver next, which will go to this ASCII num increment, and then jump back up to the solver loop up here. The ASCII num increment, we will start at the ones column of the value in ASCII num, and we'll add 1 to it and store it back. If it's less than an OA, which is less than 10, then we're finished. If it isn't less than 10, if it is 10 essentially, then we store a 0 into that position, and we subtract 1 from our pointer, and we looped back over to here, so long as S2 is not pointing at S0. And when we do it again, so we're incrementing, going from the ones column upwards, and if every time we roll over, we go to the next one up, and we roll over that one, or we increment that one. So it's like, you know, you have one of those I don't know what you call them, but you know, things where you press a button and it clicks over, counting up occurrences or whatever you do. And if we get to S2 is now equal to 0, the position that has the length of the number. If it gets to, oh, I can't show it. I need to run this for a second. Stop it here. If it gets to this position here, then what we do is we add 1 to that value, and we make this a little bit longer. We add 1 to it, and then we store it back in, so we make it into like a 7. Then we move back over to here, and we make this a 1. Because everything else should be a 0 already, and because I clear out this whole row, I can just add 1 to that, and essentially this 0, all the zeroed out area, just gets added to it, right? It can go from being essentially like from like 100, right, when it's 03, to 1000 when it's 04, right? Because we've got the zeros padding it out. But anyway, that won't work properly anymore because I've just destroyed it in there. It'd be funny to actually see this run. It's just not going to work properly anymore. Let's do that again. You know, modifying the memory while you're actually running something is not a great idea sometimes. Right, so once that's done, we come back out of this. And then we've got this walk helper which does our actual solution thing. Right, I don't need all this stack space anymore, but that's fine. That's fine. So we check, make this S50. This is going to check if we're going to be doing a silver solve or just a pure gold solve. Load in the ASCII num length, pointer, and the length. We add the length to the pointer to find out where the end of our input is. Like how long it is, well, yeah, how the length of it, the end of it, the pointer of the end of it, memory position of the last digit in the number. We shift the length right by 1, which is a divide by 2. If it's equal to 0 at this point, we'll just get out, right? That would mean that the length of it is 1, and there's no point doing it because we won't get anything. Then we subtract 1 from it. We add 1 to S0 to put it onto the first digit in the number, and we also store that into T1 because we AND it with 1 to see if we're an even length or an odd length. So yeah, this is the length. S1 is the length again. If it's equal to 0, then we just go straight down into this, storing S0 into the stack because we need that for later. If it is a 1, it's an odd number of length when we set S5 to 1 because right, this will never be true on an odd length number. It has to be an even length. Right, and then we go into this loop here. So we make our two windows, right? We add T6 to make the first window. We add 1 to the end of that window to make the start of the second window, and then we add T6 to that to make the second window. We check if S7 is less than T7. If it's beyond that, the second window goes beyond the end of the number, our target number, like this. Then we try the next smaller window by going to this try walker next. Otherwise we walk it, and then if we come out and it's T1 is a 0, then there's some non-matching number. If S7 is T7 equal to T7, then this window ended on the length of the number, and there were no non-matching numbers, so we found a solution. So we've got a result found. Otherwise, we move the start of the second window to the start of the, well, we move the start of the first window to the start of the second window, sort of thing, and we go back into this loop again. If we found a result, we convert ASCII num into a binary number. If S5 is not equal to 0, then we jump straight to add gold. Otherwise, we add to silver and add to gold, and then we're out because we don't have to check different window sizes once we have one solution. That works. Try walker next, we subtract 1 from T0 because that's the window size, we make that smaller. If it's the window size goes below 0, then we are done. There's no way of getting any more solutions. We restored S0 from the stack and we go into the T walk again, and we always set S5 here, just to make sure that if we ever get to here, it's definitely only being a gold solution, and then we fall out or we exit out, whatever. And then we've got our walk ID thing here, right? We've got our backup bit of stack, S0, S1 into there. Because we're going to use them, we're going to move them. So we load out the bytes from those two pointer positions. If they're not the same, if they don't match, then we've got an invalid one. We restore S0, S1. We make T1 equal to 0, and then we go back, jump return. If S0 is now in the position of S6, then we've found a valid solution. We've reached the end of the window, and it's valid. So we jump to there, do the same thing, except that we load a 1 into T1, and then return. Otherwise, we add 1 to each of S1 and S0 and go back through this loop. And that's it. That's the solution. It was nice that I had this here complete. I didn't have to touch this at all to fix up my solution. I had this mostly complete here in this try walker or walk trier, walk helper. That was mostly done. And I guess all this ASCII num stuff was all perfect as well. It was just, yeah, this Windows thing I screwed up a bunch of times and didn't get quite right, and it took me, and it lost me hours, unfortunately. Alright, so that is now day 2 done better. Let's see, as a bonus, because I have some extra time, let's have a look if I can. Where are we? Now, I'm going to try this on the console itself. Now it's showing that there, but it shouldn't still be there at all. I think it does hate. I think it hates resolution changes. That's what I think is going on with the recording from the PlayStation 2. Now, I don't think last time I tried this, it was very graphically bad. But I found that the Acid 2, when I ran the Acid 2 test in the emulator, in the PS2 emulator, it was graphically messed up a lot as well. A lot of sort of artifacts and lines being everywhere, and everything was rendering wrong. But I fixed that. But I haven't tried it on the hardware again to see what happens if I run it here. So maybe seizure warning. I'm not sure exactly what's going to happen. It may crash. Let's have a look anyway. Let's see if I'll have to restart this here as well. Looks like I have to restart this. Yep, and it's not rendering properly. It must be the resolution change thing that it just does not like. Look at it, not render correctly. This is wonderful. I think this is the opening animation thing. You can kind of see the pocket monsters thing at the top there. You can't. Oh, there's some characters sort of showing up. See, I have to work out what's happening here. Oh, you can see Pikachu there properly. Because it's you can see that like the text down the bottom is staying put, which is kind of odd, right? That Game Freak thing is just stuck there. Very weird. I don't know why it's like this on the hardware, but it's something that I'll work on. I'll get it working sometime. I have to say that having it working on hardware is not exactly a high priority of mine right now. But it's up there. I do want to have this working on hardware. My goal, like, is always to have it run on hardware, with the things that I've been doing on any emulator, right? Ooh, this is weird. The top part, from the top part, like the top part up here, it looks like it's updating like at the right speed. But below it just seems not to update at the correct speed at all. And then a lot of like things get left behind. Like the stuff at the very top, right? You can see that the TV is up there. It seems to be reading fairly well. Things like this seem to be reading very well, but a lot of the stuff down here just seems to be stuck, unchanged. It's very strange. Anyway, I can't reset this from my controller pad because I don't have that hotkey set up. Oh well. That's too bad. I'll get it working at some point, and I can show it off, and I can post all the code for it, and it'll be terrible. But anyway, that's going to be it because we made it. That is the last of these Advent of Code 2025 solutions that I've done. I have redeemed myself a little bit, I guess, for day 2. I'm preparing what I need to do Advent of Code 2026. I'm getting the hardware ready. I'm reading the documents that I need, but I'm still not entirely sure if I can do it fully in assembly. I might have to fudge together a bit of a C loader for the assembly that I then run inside the C, which is not ideal, but it might just have to be the way it goes. And that's it. Have a good night. Hopefully, I don't know, maybe I'll come back and I'll stream some other things again. We'll see how it goes. But that's all for now.